so let's go ahead and continue. We are going to be creating the wheel now, so I'm just going to zoom in so that way we're just looking at the wheel. This part is a little bit more difficult than the previous parts, but really it's not. So here's what we're going to do. We're going to create a brand new part file, standard IPT, and we are going to revolve this, throw out some extrusions, and just kind of see where it takes us. We're going to create a new sketch on the YZ plane, and let's just go ahead and start sketching. I'm going to start out here, out in the middle of nowhere. I'm going to come back to directly above the origin. That is our center hub. Okay, going to go straight up, out, down, in, down, out, and down. Okay. And then I'm going to use my coincident constraint to lock this in with this. Okay, so let's go ahead and add some dimensions. I'm going to put my overall dimension first. My radius is going, my radius is going to be 1. Okay, my inner hub, my inner diameter is going to be 0.28. So from here to here, 0.28 divided by 2, so 1/4. This guy up here, its thickness overall from front to back is 0.25. Okay, this thickness here from front to back is 0.125. And then the same thing in the middle right here is also going to be 0.25. Okay, I think everything's properly located, but some of the dimensions are missing, so I'm going to use my vertical constraint, and I'm going, horizontal constraint, and lock that in with that, and everything should be kind of almost okay. Okay, let's go ahead and add in some more dimensions. From here to here, this is 0.25, and from here to here is 0.75. Okay. Normally, when we work with round or cylindrical features that we are going to be revolving, we do divide everything in half. But these are giving us radiuses, so that's why I haven't divided anything in half. But what we do need to add are fillets. All of these are rounded corners. Okay, it's a wheel, so it's round. So we're going to hit our fillet button up here, and we're going to knock on all of this, and it's going to give us an error, and it's going to bother me. Okay, let's go. I'm going to undo this real quick, and I'm going to delete this dimension, our overall dimension of 1. I'm going to again do this where I have this fillet and this fillet, and I'm going to leave it at that. I am then going to change this, our fillet radius, we're going to change it to 0.063, and we're hitting all of these corners on the inside. Here, here, and here, and here. Okay. And now we're going to add that where that center point is of the arcs or of the fillets, that is 1. So I was a little bit off. Okay. So here's exactly what we need to have as far as a profile goes. Gonna zoom in a little bit. I'm gonna click on revolve. Since we didn't draw a line down here to revolve around, I am going to select my z-axis. Okay, and it revolves it like that. I'm going to rotate this to the back, and so that way I can see what I'm doing. So here's a flat surface that we're going to be working on. I'm going to select this as my flat surface, or my sketch plane, and I'm going to draw some lines. I'm going to draw 3 lines. One that was horizontal, that connected to the origin. One that is off at an angle, and then we're going to go ahead and draw in a 3rd line. Okay. So these are all going to be dimensioned. This first one from the origin, or from our flat 0 degree line, we're going to make this 15, and then we're going to make this here, from that angle, is going to be 30. Okay, let's go ahead and add in, because we're making these little cutouts, these are round, so we're going to create a circle that has a radius of 3,7 and a circle that has a radius of 6,3. So these are radiuses. We are making circles that have diameters. So I'm going to type in 0.37 times 2 and 0.63 times 2. Am I hitting the wrong thing? What did I do? I hit divided by 2. This needs to be times 2. And this needs to be, oh, that's correct. Okay. So that's exactly what I need. So I'm going to click on trim, and I'm just going to move that all the way around. Everything was properly located before we trimmed everything, so we don't need to worry about it. I'm going to finish the sketch, and I'm going to hit extrude, rotate it so that we can see what we're doing. We're cutting this out. I'm going to say yes, okay. And we're going to use a rectangular pattern where we are going to select extrusion 1 and we're going to revolve it. Circular pattern. Extrusion 1, and our rotation axis is going to be that center hub. There's going to be 6 of these guys, which is automatically selected. And we're just going to say okay. Ta-da. Done. Just kidding. We still have something to put on the front. This little peg part that pops out. Okay, so I'm going to make a sketch on this front face. New sketch. All right, and I'm just going to create a circle that has a diameter of 0.25. This circle the distance from the center of the circle to the center of the part is 0.7. So it's going to be hanging inside of the wheel, which is fine. So we're going to go ahead and extrude that by 0.125. Okay, say okay. We're just going to kind of do another sketch here. I'm going to hover over this so that that center line or center point pops up. I'm going to make a circle that has a diameter of 0.125 and finish the sketch. And we're going to extrude this by 0.125. This part is done. I know that there is a hole that's supposed to go here, but I'm not going to put it in because when we 3D print this, that hole is super tiny and nothing will fit inside of it. This part is done. Let's go ahead and save this. This is going to be wheel. This is going to be the wheel. And save. Done. Zoom out. Okay. We're not gonna do the track. The track is like meh, we're not doing it. Let's go ahead and move on to the axle peg. Yay. We're moving pretty fast, huh guys? Okay. So let's start a new part, standard IPT, and we're moving fast, so we're going to be on the XY plane. And I'm just going to go ahead and draw what I see. I'm going to be revolving it around the x-axis. I'm just going to draw this, draw that, draw this in. And I should have drawn, okay. I'm going to draw a line here. And then I'm going to create an arc from the end point of this to the end point of that. And it's going to have a little bitty arc like so. Let's go ahead and add in our dimensions. Its overall distance from front to back doesn't say. Yep. Okay, so we'll get back to that because we can find that in the thread note. All right, so from this edge to this edge, this is going to be 0.125. Okay, this has a spherical radius of 0.236. Okay, this here to here, this radius is going to be 422 divided by 2. And then this guy here, this line, is going to be 0.25 divided by 2. Okay, that looks good. for the most part. Something's missing. Oh, I'm gonna trim this because I don't know why that's there. And we are going to create this, or put a dimension there, and that is going to be 0.031. There we go. Now it's locked. Now, as far as the length of the body, or the length of the shaft of the threaded part, we can get that information from the thread note. So 0.125, or I'm sorry, 1/4 is 0.25. We're going to divide that to give us our radius, which would be 0.125. And down here at the end is 1, which is the actual length. So this length here is going to be 1. And the radius, like I said, is going to be 0.125. Okay, and that is done. Go ahead and finish your sketch. And we are going to revolve it around itself and say OK. And we're going to put a sketch here on the front. This has a hexagon head. So on the rectangle pull down menu, we're going to go to polygon. It has a hex head, which has 6 sides. And just going to draw it like that. And I'm going to tell Inventor that it says hexagon socket 5/30 seconds across the flats. So across flats just means from the flat line to the flat line, 5/30 seconds. Hit enter. And I'm going to make sure that this line here is perfectly horizontal. Say OK. And we're going to extrude this by 0.111. And it's going to cut in the correct direction. Okay. Go to thread. We're going to thread this. Super easy. It should automatically select everything. And then one last thing is we're going to put a chamfer on this back end of 0.03. Save this. This is axle peg. Next, linkage arm. Easy. Easy peasy. Standard IPT. Sketch on the XY plane. 4 circles that we're going to be drawing. 1, 2, 1, 2. I'm going to use my horizontal constraint to make sure that this is horizontally constrained to the midpoint, or to the origin, and this set of circles out here is also horizontally constrained. I'm going to click on my pull down menu on polygon and select 2-point center, and I'm just going to do something like this. Okay, say OK. Let's add some dimensions. This overall length from left to right is 3.5. I'm sorry, yeah, 3.5. It should readjust everything, and its width, or I'm sorry, its height, or center height, is 0.25. Okay. The center hole here is 0.128. And this here, the outer hole, has a radius of 1875. So I'm going to type that in and multiply that times 2. And I'm going to lock this in and click on my coincident constraint and lock it in over here. And that's that. Okay. I'm going to hit my equals constraint. I'm going to select this outer circle and this outer circle, this circle, and this circle. And it makes everything all nice and itty bitty. And then I'm going to click on my coincident constraint, zoom in, grab that guy, move it in. Boom. Done. I'm going to click on my trim button though, because I want to get rid of that line there. And I want to get rid of that line there. And say OK. And let's go ahead and finish this sketch. Zoom out a little bit and click extrude. Oop. For whatever reason, it did not select that this center hole. So when that happens, just hold down your shift key, hover over where you know that that hole is, and click. And we are going to be extruding this by 0.125. Done. Save this as linkage arm. On to the last part, which is the cow catcher. I know it sounds like a funny thing, but cow catchers actually have a real purpose. Trains still have cow catchers, but now I think now it's more like car catchers or people catchers. The reason why cow catchers existed was in the Wild West, or when trains first went across the United States. The tracks were just out in the middle of plains, so cows used to be on those tracks. So these cow catchers should move, get it, the cows out of the way. But it doesn't always work, and sometimes you end up with cow inside your cow catcher. Dead cow. Okay, let's go ahead and we're going to do some different things on this. So we're going to click on our XZ plane. And I want you guys to copy what I'm doing. I'm going to create this off of the origin. And I'm not going to add any constraints just yet. Kind of looks like a home plate. So this is what I'm actually looking for. I want to use my vertical constraint. I'm going to lock this midpoint in, or that end point with this midpoint, so that way it's right in the middle. Going to hit my equals constraint, and I'm going to click here, and this line, and this line. So everything should be properly constrained. I'm going to hit here, and I'm going to say my bottom, or this is going to be 1.8 wide, or from top to bottom. This guy here is 0.25, and from front to back, this is 1. Done. Not really. Click on our coincident constraint, grab that center point, and lock it in onto the origin. There you go. Now it's done. Finish your sketch. What we are going to do is, because the top profile up here has a different shape than, or different size than the bottom, even though they're the same shapes, they're different sizes. So we need to go ahead and create an offset plane, because if we extrude it, it's just going to be a solid, straight, even thing. What we're going to be using is loft. So we're going to create an offset from plane. We're going to offset from the XZ plane, and we're going to offset it by 0.75. Okay, so now we have a brand new plane. This brand new plane we're going to create a new sketch on, and we're going to do the same thing. I'm going to draw it off of the origin, away from things, because I don't want to get confused as to what I'm doing. Making a basic same shape. Oops. So I should have like a home base type shape. I'm going to make this line and this line equal with each other, and this line and this line equal with each other, and then I'm going to hit my vertical constraint and make sure that that lines up with the midpoint there, and it does. Okay, let's add some dimensions. This is going to be 0.25, and then this is going to be 1.20. Okay, gonna hit my coincident constraint to grab that midpoint there and attach it to the origin. And it did that because I forgot to add one last dimension from front to back. This is going to be 0.75. Okay, so you guys see that it is the general same shape. We're gonna finish the sketch. Okay, and we are going to click on loft. So lofting is pretty simple. It needs a few different sketches in order for it to work. So we're going to click on the top sketch, which is sketch 2. Click to add over here and grab the second or the first sketch, and it will create something that looks like this. And we're going to say OK. And that's that. I'm going to grab that, and I'm going to turn off its visibility. Okay. So this cow catcher is hollow, looking at this bottom isometric over here where we see that it's hollow. So we're going to use our shell feature. It's pretty easy, pretty snazzy. So we're going to click on shell. It brings up this dialog box, and Inventor knows that we're going to make it hollow. What it wants to know is what surface are we going to remove in order to make it hollow. we're going to remove this bottom surface, and we're going to tell it that the thickness of this is 0.1. Okay, automatically done. So we're just going to say, okay, done. Easy peasy. Next, we're going to make a sketch here on that surface. If you guys run into trouble where you don't have a sketch popping up, it's because you missed a dimension somewhere. So I'm going to project my geometry. I'm going to click on offset, and I'm going to make this little window that is 0.1 in. Say finish sketch, extrude, and all we're going to do is extrude it by 0.05. And we're going to cut in. Make sure that you change the direction and say OK. We're going to do the same thing over here on this other side. Click on project geometry, grab that, offset 0.1, finish sketch, extrude, grab that, change it to cut in by 0.05, done. Last thing that we need to do is put the little holes on the backside, or the little pegs. So the pegs are going to go in a triangular shape, and I'm just drawing them different random sizes. Going to click on my equals constraint, hit all three of those circles, and then dimension one of them. The dimension of this one circle is going to be 0.125. And I'm going to use my horizontal constraint to lock this in with this, and then use my vertical constraint to lock that in with the midpoint, or the origin. Okay. I'm going to put in my vertical locations for these. This is from the bottom. This is going to be it does not say. So we're going to guess. We're going to put in 0.125. I think that sounds like a good number. And then our vertical location for our top circle is going to be 0.5. And then our horizontal locations from the middle or from the origin, this whole or circle on the left is going to be 0.625, and then from circle to circle, center to center, so make sure that you are dimensioning center to center, is going to be 1.25. No, 1.2. Wait, 1.25. Done. Okay. Finish your sketch. This is done. Let's go ahead and extrude all three of these profiles by 0.125. Cool. Done. Okay. I just noticed I found the information that I needed right here. Let's go back into sketch 5. And I'm going to delete this number, this dimension, the 125. And I'm going to delete 0.5, our vertical locations, because it should be from here. Oops. From the top to the center of this circle is 0.125. And then from circle to circle is 0.5. So it was the same thing. I'm dumb. Whatever. Just better safe than sorry. Cool. Done. Save this as cow catcher. All 9 parts have been created. The only one that hasn't is the track, but that is not included on the full assembly. In the next video, I will be creating an assembly file, show you how everything should be laid out. So at this point, go ahead and save your stuff. We've been working for another 25 minutes. Take a little break, come back to video number 3.